In the last video, we ended up with giving some of the quiz questions. This video, we will solve these questions. So let's start with first question. It is also De Morgan laws. De Morgan laws. So there are two parts of the laws. One is says that A union B and its complement is equals to A complement union B complement. So that's one rule. And second rule is basically just an opposite from union. It says A intersection B and complement of that is A complement union B complement. So let's see how you prove this. So it says you have a universal set right? You have a set A and you have a set B, and this is a universal set. Okay? So A union B is basically nothing but this group. This is A union B. So A union B complement is basically anything outside this function, right? So let's mark it by a blue color. Right? This is A union B, which is this, and complement of that. This is the left hand side. Let's see the right hand side. So it takes the same inside, right? So you have A. So let's say what are the complements of A. So A complement is basically this. So this is A complement. So universal set is basically now anything but A for this problem, right? Now add B to it. B to the remaining portion, right? So now the universal set for B is anything but A, because we said A complement is a universal set. Now it says intersection B complement. So what is B complement? So this is B complement, right? This is part of A complement. So A complement intersection B complement is same as A union B complement, which is basically X says that X belongs to universal set and X does not belongs to A and X does not belongs to B. This is De Morgan law 1. So second De Morgan law, he says A union B So how do you define A union B? So if this is, say, A, and then this is B, then A intersection B is this value. Right? This is A intersection B. So anything outside this A intersection B and part of a universal set, right? So anything which is outside this value but part of universal set, which is basically all of this. So anything except these values. So remove the red one, except these values is A intersection B. Remove except this value. This is A intersection B, which is this, and its complement, which is anything outside this. Now let's see the other one. So you have A, now it says A complement. Right, so again let's see, there is a universal set. So A complement is anything outside A. Right? And union B complement, which is anything outside B. So anything outside A includes this value, and anything outside B also includes this. So this is the only value which belongs to both A and B. So this value is out of A complement union B complement, right? So except this value, everything is A union B complement, which then is equal. Now let's solve this. A minus B intersection C is A minus B intersection A minus C. Similarly, A minus B intersection C is A minus B union A minus C. So let's see, there is A, there is B, let's make it better, there is B, and there is C, right? A, B, and C. So B union C is this component. Right? All of this and all of this is, so all that is marked in B is B union C. Now if you subtract A, which is this, so anything, so A minus B union C, this implies anything that belongs to A and do not belongs to B union C, right? So anything which belongs to A, which is this full, but does not belongs to B union C, which is then, so anything which belongs to A but does not belongs to either B or either C, so that is an answer, right? So this is the answer. Now let's see A minus B. So let's see in the right hand side. So it says A minus B. So A minus B is every element which is this, which belongs to A but does not belongs to B, right? Now if there is also C in it, then A minus C is anything which belongs to C, which does not belongs to C but belongs to A, which is this, right? So the only common element it means is this, which is same as before, right? So this is nothing but A minus B intersection A minus C. Similarly, you can prove the other functions. I'm not going into the details of proving all other properties, but if you look, the idea is to, like, if you start thinking in Venn diagrams, you would be able to understand these identities and you can easily prove what these identities are, right? I will also encourage you to remember these properties because these properties could be helpful in solving a lot of the set problems. So let's go back to those quiz questions which talks about all of those properties. We have already proved this property, which is De Morgan law. We have already proved distributive law, which says A union B intersection C is equals to A union B intersection A union C. Now think about it. So B intersection C, right? So if you have B, right, and if you have C, then this is the value which is intersection, right? And then if you also have, if you take this with union of A, so this is A, and then this is full element that will come, right? So all of A as well as a B intersection C, which does not belongs to A. Right? So this is, there is a small element of which then is A union B intersection A union C. So this is called a distributive law. Similarly, there is a cumulative law which says A union B is equals to B union A, and A intersection B is B intersection A, right? This is very clear. Associative law, which is an opposite of distributive law, is A union B union C, which is basically all of A, all of B, all of C is similar to A union B union C, and similarly A intersection B intersection C is A intersection B. So these are associative laws. Anything intersection with phi has to be phi, and anything intersection, so if you intersect anything with phi, right, it's basically phi because the common element is phi, and if you put anything which is intersection with a universal set, is basically the set itself, right? The set is the universal set. Similarly, if you say union of phi, then it's basically everything which belongs to A as well as belongs to phi, which is basically then A. And similarly, if you say A union universal set which belongs to A as well as belongs to, so X belongs to A and X belongs to U, and since A already belongs to U, therefore, or A is a subset of U, therefore this is U. A intersection B is subset of A. Yes, because if there is a set A and there is a set B, then A intersection B is basically a part of A. So it's a subset of A. And it's also a subset of B. Right? Similarly, A is subset of A union B. Yes, because it contains both A and B. A union B contains both A and B. So both A and B is a subset of A union B. So it's A and B, then A union B is this, right? So A belongs to this and B also belongs to this. If A is subset of B, which means if this is A and this is B, then A intersection B is A, right? So if you see the intersection part between A and B, it's basically A because it belongs to B. It's a subset of B. And similarly, if A is a subset of B, then A union B is basically this whole set. If you see A and B, if this is A and this is B, then A union B is basically nothing but this full, which is equivalent to B. So again, the idea is not to solve each and element of the quiz. The idea is to, as long as you understand Venn diagrams and you're able to draw Venn diagrams as stated, you'll be able to prove properties of sets. I will encourage you to remember some of these properties, as these properties will be very helpful in solving mathematical problems. So this last thing which is remaining in set of operation is Cartesian product. What does that mean? If you have set A, which is value 1, 2, and 3, and you have set B, which is value 4, 5, and 6, then A cross B is basically, so what does that mean? So each element is combined with each element of B. So 1 is combined with 4, one is combined with 5, one is combined with 6, similarly 2 is combined with 4, 2 is combined with 5, 2 is combined with 6, 3 is combined with 4, 3 is combined with 5, 3 is combined with 6. So this is A cross B, right? Similarly, B cross A would be the opposite, right? So 4, 1, 5, 4, 2, 4, 3, 5, 1, 5, 2, and so on. Clearly, A cross B is not equal to B cross A. If I have to represent Cartesian product in a set builder form, how would you represent it? So we say A cross B is all elements of A and all elements of B such that A belongs to A and B belongs to B, right? So all combination of A comma B where A belongs to A and B belongs to B. And similarly, if I say B cross A, so it's basically B comma A. So all combination of B comma A is such that B belongs to B and A belongs to A, right? So this also suggests A cross B is not equals to B cross A. Only time when A cross B will be equals to B cross A. So if A cross B is equals to B cross A, this implies A equals to B. So with this we also conclude Cartesian product, and we also conclude different properties of sets. So we conclude sets. In the next lectures we will talk about relations.